Hello, and welcome to our webinar, Modernize Your Banking Platform with Temenos and NuoDB. My name is Josh Verrill, and I will be moderating today's webinar. I'm joined here by Joe Leslie, a Senior Product Manager for Cloud Native Products at NuoDB, and Nanda Badrapan, a Product Director for Cloud Technology Solutions at Temenos. In this webinar, Joe and Nanda will review how to lower IT costs and ease your management burden by moving your legacy stateful SQL applications to hybrid, private, or public cloud environments, how to scale out on demand to meet ever-changing application workload demands, how to deliver continuously available applications that meet your aggressive SLAs, how to simplify your build, deploy, runtime, and monitoring processes with cloud-native solutions by leveraging the benefits of Kubernetes, operators, and persistent storage, and what is the importance of multi-cloud and how it can be used as a differentiator when deploying enterprise banking applications. At the end, we'll open it for some Q&A. Before we begin today's presentation, I'd like to review a few logistics. Our webinar will last about 45 minutes. The webinar will be recorded, and the video of the slides will be made available for replay. Attendees will be muted during the call. However, you may submit questions at any time during the presentation using the questions box in the GoToWebinar control panel. So with that, I'll turn it over to Joe. Joe?
Great, thank you, Josh, and thank you all for joining us today. Nanda and I look forward to spending most of this next hour reviewing this important topic with you. Before we jump right in, we'll just say a few words about who we are and our roles at our companies. I am responsible for our roadmap and delivery of NuoDB products and solutions that deploy in cloud-native environments, like Kubernetes or really any container-native deployment model. In addition, I also look after our admin management tier as well as our NuoDB Insights visual monitoring product. And again, happy to be hosting you today along with Nanda. Nanda, could you also just take a few moments and share a little bit about your role at Temenos?
Sure, Joe. Hello, everyone. Thanks for joining the session today. Really appreciate it. My name is Nanda Badrapan, Product Director, Cloud Technology Solutions in Temenos. My primary responsibility is to build cloud-native reference architectures for public clouds and for software as a service. In addition to that, I also look after executable architectures, i.e. automation, infrastructure, and deployment.
Excellent. Thank you, Nanda. All right. So let's go ahead and review a bit of what we plan to cover today. So today we're first going to cover some of the benefits of modernizing your enterprise banking apps. Some of those benefits we'll be covering will be lowering IT costs and the management burden associated with owning your own IT infrastructure. We'll also be covering the benefits of scaling elastically to meet ever-changing workload demands, and then also covering continuous availability and how, when using cloud-based and native technologies, how Temenos and NuoDB can deliver on these important areas. So we will spend a good chunk of time reviewing Temenos and NuoDB, the approach as underpinned by Kubernetes, and we also have a nice demo prepared that actually shows you Temenos Transact and NuoDB running together, delivering on these benefits that we'll be sharing today, and then we'll have some time for some Q&A. So with that, and before we jump right into the main heart of the presentation, we would like to describe some of the trends that we've seen starting in 2020, and we also see continuing through 2020 and beyond, that are really driving a lot of the conversation of what we're talking about today. And we're seeing many of the organizations that we work with increasingly see benefits by moving their application workloads to the cloud. As a main tenant. And then also, I'd like to ask Nanda to share a bit of what he's seeing in the banking industry as a major trend. Nanda?
Yeah, sure, Joe. So that's the trend we see these days. We see CIOs of the banks asking for multi-cloud solutions, of course, for a number of reasons, as they start to see the value. If it's all about cloud adoption last year, it's all about coming up with a solution that could work across multi-cloud. That's the trend, main trend we see in the banking industry in 2020.
Excellent, thank you, Nanda. And then the last trend, which should be no surprise, is Kubernetes continues to just cement its place as a containerized orchestration platform in the marketplace as it continues to evolve and mature as the cloud native platform of choice.
Yeah, we can see that the industry is consolidating infrastructure with Kubernetes. So I would expect Kubernetes continuing to evolve as the cloud native platform of choice, as you just mentioned.
Excellent. Thank you, Nanda. All right. Well, with that, let's go ahead and talk about why this move to the cloud and why now. So there's a few major points that we wanted to share in this area, and the first one is this idea around cost savings, right? Relieve your company of IT infrastructure deployment and all those costs associated with that type of infrastructure. Secondly, in the last 5 years or so, there has always been questions. Well, is the cloud ready to move my critical applications there? Is it secure? Is it does it perform well? And we're really here to say that cloud service providers today are meeting the security and the performance and ease of scale and really all this resilience and reliability requirements that your business has. So that's why we are seeing a big move to the cloud. And the other aspect that the cloud delivers is this flexibility of risk. You can really decide almost with a dip your toe approach to the full head plunge of moving to the cloud. You can dip your toe by simply moving your workloads into the cloud using a very similar architecture of maybe virtual machines. But then you can, as I called it, that full head plunge where, you can go in with a multi-cloud, approach using cloud native technologies like Kubernetes. So, how do you get started? So Nanda, from your viewpoint, how could our listeners get started when moving to the cloud when considering like a Temenos and NuoDB solution?
Yeah, sure, Joe. I think you covered it really well, why our customers should move to the cloud. I'll come to the how part in a second. For me, the real differentiating factors in moving to cloud are basically cost. It's capital expenditure free, speed, huge amount of computing resources are available at the press of a button. The third one is global scale, which you did cover, right? So easy to deploy applications and scale elastically on demand across multiple geographies. These are the main, selling points why our customers should consider moving into the cloud. So once they made that decision, yes, I'm going to move to the cloud. How Temenos and NuoDB can help us? Well, that's a great question. Together, Temenos and NuoDB enable our customers smooth transition from legacy infrastructures to a modern cloud-native architecture using proven reference and executable architectures. So we have done all the hard work for you, and you can make use of that. That's the idea.
Excellent, thank you, Nanda. All right, well, that takes us into a little more detail on some of these areas of cost, and then also how we can apply some of that savings. So maybe you have yet to start your journey into the cloud, or perhaps as many have already started the journey into the cloud, and what we've seen is many will first start to migrate their stateless applications to the cloud, and that's perfectly understandable. It's a way of realizing early gains, early cost savings, as well as, as I mentioned, reducing that risk. But then many companies are then looking to increase their yield and their benefits, and they start considering moving their stateful applications, and that is a larger project, and it's one that we are certainly here to help as you consider moving banking applications with relational databases to the cloud. So when trying to address some of these bullets here, that could simply be looking to swap out more expensive legacy database products for NuoDB. This is where you can gain that cloud native distributed capability, yet not give up any of those important SQL relational database tenants that you rely on, like anti-standard SQL, ACID compliant transactions, and of course then you also would not need to go through a large application rewrite as well, since your existing SQL will continue to run. So that, along with deploying active lower cost commodity hardware, are all benefits, and as a result, you're reducing your hardware and infrastructure and IT costs, including IT expert staffing costs. So these are some of the benefits and that you would be able to realize. Okay. And so I think one of the, certainly not one of the main benefits of moving to the cloud is some of these cloud native capabilities. And one of them is this idea of easy scale out, elastically scale out and scale in. Maybe you could take us through, how you're seeing the ease of scale as we deliver this capability for our customers.
Sure. So while moving to cloud and then running natively in cloud are very important, however, having a cost-effective architecture deployment model is very important too, right? So one of the reasons why we would move to cloud is we want to save on the expenditure, we want to save on the expenses, right? So ideally, it's very important that we have a very cost-effective architecture. There is a strong reason for this. Applications experience peaks and valleys in the real world. The application should be able to scale elastically during load and scale back during idle times. That's what cloud gives you, right? So using Temenos Transact and NuoDB underpinned by Kubernetes or cloud native technology, our customers can scale out and scale back in to meet the application transactional throughput requirements. So that's how we add value to the whole equation.
Excellent. Thank you, Nanda. And the next area we wanted to cover is another popular benefit when moving to the cloud. And this is this whole idea around continuous availability. So we did want to spend a few minutes talking through this important benefit and how our solutions deliver here. So the idea here is that for today's enterprise applications, especially banking applications, they require continuous availability and they must stay running, and there are no exceptions. Temenos and NuoDB together, underpinned by Kubernetes, really work all together in a chorus to ensure that continuous availability is always provided. Even in the event of common hardware, software, network failures, we know these failures are going to occur. In fact, our solutions plan for them. It's really our strong belief that failure events should not result in downtime. When proper redundancy is planned into the system and implemented, systems will continue to run. In fact, the result can be the end users will continue to work through their daily application tasks, even when failures and recovery events are happening, and they will be completely unaware. And that's exactly what our goal is, right? We want their work to continue and not be impacted by the any failure events or any as the recoveries are being orchestrated, all of the self-healing events. End users continue to work, and that's the whole idea, and what we're what we're delivering on when we say truly continuous availability. Continuous availability is also not just failure events, but there's also operational downtime, right? Rolling upgrades and things like that. So it's planning for failures, but also then planning for all of the proper tasks that we know need to happen, software version upgrades and so on, that they all happen in a rolling form such that applications continue to run 24/7 by 365. With that, we wanted to also spend a little bit of more time talking about the NuoDB architecture, why it's so different, what is it about NuoDB that is delivering beyond what the traditional RDBMS architectures deliver. And in this slide, we have a visual that really tries to show some of the core differences between what a traditional RDBMS architected, decades ago, compared to a more modern architecture that NuoDB provides that allows a database to deliver all the same capabilities, but in a distributed environment, right? Running a database across locations. Those are, could be on-prem data centers, a hybrid cloud, in the multi-cloud, and all have it work as it did as a traditional system. So what we see here in the diagram, we see the traditional relational database, that the core component here, we have a query processing engine and a storage management engine, but they're very tightly coupled together, right? Almost like in this tight magnetic bond, right? It's very hard to break them apart. So whenever you look to scale a solution, you're carrying these pieces along, right? It's a very heavy piece of software that does not scale well when you need to quickly either scale out or scale back in. In contrast, if we look at NuoDB's architecture, we see fundamentally that the transaction components and the storage management components are running in separate processes, right? We have these TEs, which we call transaction engines, and they're responsible for connection management. So you have the applications that will connect into the database through an assigned TE. And that's where the SQL is then parsed, optimized, and executed. But when the SQL runs and it's, let's say a DML, sort of like a update, insert, or delete statement that needs to persist to disk, then the transaction is then handed off to a storage manager. Or if you have multiple storage managers, is handed off to all active storage managers to then persist that transaction to disk. And again, those we'll see are also running in separate processes. By this nature, it means that NuoDB can scale out its transactional and storage durability components separately. So depending on the type of application, you could potentially need to scale out many transaction engines to meet a particular application workload. And then depending on the durability requirements, you can have 1, 2, or 3 copies or more of your data, all again, your choice, all based on your application requirements. So, when we start to look at these benefits, some of these, we've talked about, and reinforcing here this concept around ease of scale out and scale in, the continuous availability, as in once you create redundancy at each one of these transaction layers and the storage layers, the redundancy allows us to then, if for any reason you lose a transaction engine or a storage manager, it's okay, because there's other transaction and storage manager processes that will pick up the workload. So that's how NuoDB is able to stay resilient and always available, because you effectively deploy it by creating an army of transaction engines and a suitable number of storage managers that you're always going to be protected in the event of a failure. Due to the distributed nature, you're free to choose. Is it on-prem, private, public cloud? You can run in a physical or virtual machine environment, or any of the containerized environments that we've really been focusing on in today's conversation, as for example, Kubernetes. And just to reinforce again, NuoDB is just like, it's going to run SQL just like that traditional database. It is an ANSI standard SQL database product. It adheres to ACID compliant transactions. So all of your transactional and SQL requirements are covered. NuoDB also supports visual SQL development products that are Java-based, as well as visual monitoring and diagnostics tools. Okay, so that's just a good high-level review of what the NuoDB architecture is and how it helps provide some of the inherent benefits that we've been talking about today. So with that, we've really been talking a lot about Temenos and NuoDB bringing their best of breed capabilities in their specific domain areas to deliver on advantages of modern architecture and low touch management, as we've been describing. This is sort of the peanut butter and chocolate moment, as the slide is indicating here, where Temenos and NuoDB together allow for easy cloud native migration from more expensive hardware to maintain these legacy tools that we don't want to just throw away, but we want to continue to take advantage of. And all this allows you to focus really on your company's strengths. If the Temenos and the NuoDB solution are making, reducing management burden and the cost of maintaining applications, it really allows you to really focus on, your company's strengths and doing what you do best. And so really next up, Nanda will lead, and he and I will take you through a demonstration of what we've been talking about and sort of show it so you can see for yourselves the benefits of a Temenos and NuoDB solution. So Nanda, I'll let you go ahead and describe what we're going to see here in the demo, and I'll flip the slides for you and start the video when ready.
Sure, Joe, thank you. I must say I quite liked when you mentioned, peanut butter chocolate moment. That's really interesting. Right, let's get straight to the demo. Right, so here, today we're going to show you a demo of Temenos Transact with NuoDB running in Google Cloud, specifically Google's Kubernetes engine. So that's the demo we're going to show you today, but the same solution, Temenos Transact and NuoDB, we have got reference architectures, we have executable architectures, proven, tested architectures available on AWS ECS Fargate, EKS, Azure AKS, and also for hybrid clouds, on-prem implementation in Red Hat OpenShift as well. Right, Joe, would you mind switching to the next slide, please?
Excellent.
Cool. So this is the reference architecture for T24 Transact on Google Cloud, powered by NuoDB. So here, before we go straight into that diagram, usually takes about 20 minutes to 30 minutes to explain every single box in this architecture diagram. I'm going to give you a quick and brief overview of what this architecture is all about, and then I will take you straight into the demo. I know everyone is waiting to see that demo. So basically, T24 Transact, or Temenos Transact, is a classic 3-tier application. There is a web tier, app tier, and a database tier. and we use a JMS 1.1 message broker, which is the messaging layer for availability and scalability reasons. The rose-colored box that you see on the screen is the VPC within which we have deployed, Transact, and NuoDB on Google's Kubernetes engine. So your architecture, needs to be isolated and secured within a public cloud. That's why we placed it within a VPC, and it gives you your own private address range as well. So with that, basically, there are a lot of managed services scattered around this reference architecture. We call them as perimeter services. To operate any system in cloud, you need a number of managed services that are offered by the public cloud platform. For a number of reasons, right? So you would need an API management solution, you would need a key management solution, secret manager, web application firewall, or logging and monitoring tools. Of course, you would need a container registry, a number of managed services that make up an end-to-end solution. So these are scattered around this reference architecture. So idea is basically to make use of the managed services that the platform offers, so that we run natively in that target cloud. Right. So this architecture basically has got two set of users: internal users, which are the bank staff who connect to this architecture through a secure VPN, and the external users are the customers of the bank who connect through channels. Basically, we call them as channels users as well. As you can see here, right, the web tier of the architecture. When I say web tier, it's the user agents and the public-facing APIs. They are deployed in the public-facing Kubernetes cluster. The message broker is deployed in its own Kubernetes cluster, and the application logic Transact itself is deployed in its own Kubernetes cluster, and NuoDB is again deployed natively in Kubernetes. Those who are very comfortable with Kubernetes may ask this question: why do you need a lot of Kubernetes service clusters here? Well, not necessarily. It looks nice and self-explanatory in the diagram. However, as you know, you should be able to run all this within one single Kubernetes cluster. And at the very bottom of this architecture diagram, you can see the serverless workload. Basically, you can see Kafka running on Kubernetes and our serverless workload, basically. So we are working on a proof of concept on Google Cloud Run, which is Knative based. By the time you come around to see this architecture in a few weeks from now, obviously you would see Google Cloud Run stroke Knative in this architecture. So that's a very quick overview of this architecture. The bottom line is the solution, Transact and NuoDB, runs natively in Google Cloud on Google's Kubernetes engine. That's the bottom line. Now, with that in mind, if we switch to the demo, then it will all start to make sense. So here,
I'll go ahead and start this.
All right, cool. Thanks, Jay. So this is a recorded video. So the end-to-end demo takes about 40 to 50. What we have done is we have edited this video just to bring it down well under 20 minutes so that you can experience it within a shorter duration. So what we're going to demonstrate today is basically, the architecture that I've shown just now. We're going to put some load through. As you can see, the load is already going through the system, and then we will show you how nicely this architecture scales out and scales back in when we stop the load flowing through this system. Before we proceed further, let me give you a quick tour of this dashboard so that it all starts to make sense for you. Let's move to the left-hand side of the dashboard. On the top, we see the message broker count, which is the number of messages in the message broker. Under that, you see Transact CPU, followed by NuoDB CPU, and at the very bottom, you see NuoDB commits. On the right-hand side, at the very top, we see the number of transactions per second. This is the load that we are putting through to the system. We are using JMeter to pump and load our transactions through the system. Under that, you see number of nodes per availability zone. We are using 2 availability zones, each with 1 node. Under that, you see transact and NuoDB transaction engine scaling details. Transact is set to scale from 1 to 30 under load. As you can see, it's got already 4 replicas already. NuoDB TE has got 1 number of pod as minimum, 1 pod minimum. It can go scale up to 6. At the moment, it has got only 1 replica. As you can see, the load is going through the system. And at the moment, we are pumping in about 18 transactions per second through the system. We are using a CPU-based metric to scale the pods. As you can see, so when the CPU utilization goes beyond 30%, more pods will be provisioned. Transact is currently running with 5 replicas. NuoDB is still managing with 1, and we're still putting constant load through the system. As you can see, we have on average about 200 odd messages sitting in the message queue, right? So obviously, the system will start to scale to process the messages in the message broker.
So Nanda, it looks like that's about to start. I noticed down in the NoDB TE target area, we're at 34%. We've just increased over our target, so we'd probably start to see another replica being added soon.
Oh, you're spot on there, Joe. There you go. You got 1 more TE pod just provisioned and started to take over the load. Brilliant. Oh, did you notice that we got 1 more node in the availability zone A? So basically we got more pods in the transact, and we got 2 nodes in TE as well. So in order to accommodate these additional pods, absolutely gone up to 2. So now we are bombarding the system with a lot of messages. We are pumping in about 40 odd transactions per second. And obviously the number of messages in the message queue will start to build. I think it's about 700 messages now, isn't it, Joe, in the message broker?
Yeah. What's nice about the interface too is, we can see here just at the top, it's showing the last 30 minutes, but our users would also be able to drill in and investigate based on their preference. They can choose last, 5 minutes, 15 minutes. They can choose an interval of how often to refresh. The interface also supports a kind of left click, slide, and drill into any particular workload area for deeper and more, further investigation.
So we have about 1K messages, waiting to be processed in the message broker now. Transact is now running with 29 pods. In order to accommodate these additional number of pods, the number of nodes in each AZ has gone up. The AZ1 has got about 4 nodes. AZ-B has got about 3 nodes. Each AZ it can scale up to 5 nodes. At the moment, they're running with 4 and 3. We got 29 replicas on Transact. TE, we got 3 pods. So the system is behaving really well. It's taking on the messages in the message broker and is doing really well. So we are still carrying on putting more through the system to prove that the scale can take on this load, though it's running in peak capacity, right? So we've got about 29 pods running in Transact and 3 on TE. We're putting in more load through. We're about 80 transactions per second putting through the system now. There are a lot of messages in the message queue. As soon as the system scaled, the number of messages have come down in the message broker. So now Transact is running with peak capacity. We got about 30 pods. That's the max we've allowed for Transact, and TE has hit the max as well. It's running with 6 pods. Now, in order to accommodate these pods, both the AZs have gone up to 4 nodes, though they have capacity to go for 1 more node in each AZ. but there's no more pods to be processed, no more pods to be provisioned. So they've reached the peak capacity, and the injector is still pumping messages through the system, and the system is still able to process and the incoming messages.
Looks really good, Nanda.
Yeah, we've ramped up now, haven't we? So we've gone up to 120 transactions per second. Obviously, we are putting more load through. The system is going to hold together. It's going to process all that load. So so far what we've done is basically we've put in a load through at different phases to show how the system has scaled step by step and has reached the peak capacity now. And obviously, we will leave it there for some time to show that the system is carrying on processing the load with no issues. And then we will take you through the scaling as well slowly when the system has finished processing messages and there's nothing else left in the system, and then it will start to scale in back. So let's keep pushing messages through the system just to demonstrate that the system scaled elastically and is still able to manage the load.
What's wonderful to see, Nanda, is how the system is really responding to the application workload automatically based on the auto-scaling capabilities. We don't need operators that sort of stand by to, pull all the levers or push the buttons to ensure that the system is scaling up or scaling down. Is just all happening in an automatic fashion, which is terrific. Sort of what we would expect from a modern architecture.
Absolutely, Joe, and it makes a lot of sense when you see it in real time.
Absolutely.
So you can see we are putting more load through the system step by step to demonstrate, the system is, doing really well. I think it's about time, Sorry, Joe, go on.
Yeah, I was just going to mention too, I know in this particular panel, we're showing, CPU and commits and so on. I was mentioning earlier about some of the capabilities of the visual monitor, but other screens are available that show full details of the, the disk file system, the IO read and write rates, along with, what's common in database monitoring. We can typically see wait events, waiting for what is the next resource. So all of these visual screens are available by simply selecting to the left the pull down, and you can then view the different metrics that the product provides.
Cool. So we'll still keep on pumping in transactions through the system, and at one point in time we will stop the load going through, and then you will see the number of messages in the message queue start to come down, because you've got about 30 pods waiting to process the messages when you're not putting a load through, and obviously the messages in the message queue will start to come down, and at one point in time there won't be any messages left to be processed. And you no longer need all these 30 pods and 8 GCE instances waiting to process your messages, and the system recognizes that, and it will automatically start to scale back in. So as you can see, we're not putting any load through the system for some time now. You will see the system will start to scale back in. Oh, there you go. Transact has now come down from 30 to 4, and the transaction engine has come down from 6 to 3. Usually the node provisioning and node deprovisioning takes some time. So we will start to see a number of nodes starting to come down as well.
Well, that's excellent, Nanda, too. And it seems like it figures out fairly quickly that the load has balanced or rebalanced, and then is deciding it's the right time to scale back.
Yeah.
Because what's nice is I don't see seesawing. I don't see a lot of thrashing. It's seems to be scaling out and then scaling back in rather well.
Yeah, I think it will be quite soon. We will start to see the nodes, the count of nodes starting to come down. So we're still running with 4 pods in Transact and 3 with TE. It's about time they will start to come down as well, I guess. So we started with 1 node in each AZ, isn't it, Joe?
Yeah, that's right. Yep.
Yeah, and obviously 1 pod with Transact and TE. We scaled up to 30 for Transact. We scaled up to 6 for NuoDB transaction engine, and now we're starting to scale back here. Has done really well. The system has performed really well. Okay, Transact has gone down to 3 now.
Yep.
Oh, there you go. Transact gone down. Oh, sorry, it's 3 still. Okay.
Yep. And I guess the last thing we'd be looking for, Nanda, is that the node counts would be falling back. But as expected, they would be the last. They're the larger resource requiring nodes within the cluster. You probably don't want to thrash and bounce those up and down too quickly.
Absolutely. But it's good that it takes time so that we get to witness, the scale out and scale back nicely. T has come down to 2.
Oh, yeah.
Yeah. I think it's good that you mentioned, different dashboards are available where you can see different sort of metrics. Yeah, that's good.
Yeah, I myself find it very helpful as well to see there's a SQL dashboard. It shows you, the mix of your SQL from, selects to, updates, inserts, and deletes, so you can really see kind of the activity as it's running against the database. Another one of the dashboards is the number of connections, right, to see the actual connections to the database and the workload each is producing. So there's quite a rich set of dashboards that give a full view of monitoring and diagnostic information.
Good stuff.
I think one of the other nice aspects too is, and we have a video here so we can't see it, but as I am cursoring now, when you cursor over these, it would actually show you, what each one of them are. So you can see some detail of the lighter blue and the darker blue, which of the ones in the key below are actually contributing. It's really helpful when you're on the NuoDB process screens, because then you can see the memory and the CPU that are being the resources consumed for each transaction engine and each storage manager.
Cool. Joe, did you notice that the number of node instances have started to come down? So now we're running with 3 in one AZ and 2 in another one. Transact has gone down to 2 pods as well. NuoDB running with two as well.
Yeah.
Yeah.
That looks excellent, Nanda. I think we're probably good to finish up. I think this has been tremendous demo here that's showing the benefits of Temenos and NuoDB in this sort of modern cloud native architecture, especially showing off all of these auto scaling capabilities. Is there anything you wanted to conclude with on the video?
No, I think we are good for now, Joe. Either we can wait for another minute or two to see, we're going back to where we started with the one replicas in each layer of the architecture and one nodes in each. But I'm sure our listeners would understand it's about time. In another minute or two, they all will come down to one, back to where we started. So we're good.
Yeah. Okay, excellent. Well, thank you, Nanda, so much for taking us through that. Really very impressive demonstration. We'll slide back to our slide deck, and we'll just finish up with some last remaining concepts. I know one of them is we wanted to talk a little bit more about the importance of multi-cloud. For me, Nanda, I know we talk about all these different clouds in our daily work, right? We have concepts and terms like on-prem and private cloud and hybrid cloud and public cloud. And, I thought it would be really good, especially if you could take us through, this newer concept of multi-cloud and what the benefits are, so our listeners can really see from our perspective, the importance around what multi-cloud is and how to benefit from it.
Yeah. Sure. There's two things that we see in this year 2020: hybrid cloud and multi-cloud. Multi-cloud is gaining momentum. So let me quickly explain what is a hybrid cloud and what is a multi-cloud, and why multi-cloud is preferred by CIOs these days. So when I say as you mentioned, Joe, we've been hearing on-premise, private cloud, public cloud, and even hybrid cloud for some time now. So a hybrid cloud is simply a deployment that includes both private and public clouds. Why would I choose hybrid cloud? Well, I run my primary on-prem that has got limited capacity during peak load. I want to make use of, public cloud. I want to scale out. I want to burst out to public cloud. I want to make use of the availability and the managed services in public cloud when there's no load, and I want to shrink back into on-prem. So this is one model you see in the industry these days, right? I want to run on-prem at the same time I want to burst out to public cloud. So we call it as hybrid cloud deployment. The other one is multi-cloud. Multi-cloud refers to a cloud deployment that is made up of more than one public cloud, right? So last year and the year before, it's all about we want to move to cloud, we want to run natively in cloud. That was the trend. But now people, and especially senior execs within the bank, CIOs specifically, they are looking for multi-cloud solutions. This is for a number of reasons, right? So the first one is basically this gives them the immunity from specific public cloud provider outage. If there is a specific outage in a specific cloud provider, the customer's business can continue to operate through the secondary public cloud provider. But the one thing is your solution should be able to run across multi-cloud. If you got a solution that runs across more than one cloud, you are covered by service interruption from any one specific public cloud provider. The other advantage is basically it gives the power to negotiate public cloud contracts that avoid a permanent lock-in. If you're running in two different clouds, if one is expensive, you got the opportunity to move into another, or it gives you the flexibility to negotiate. The other one is it gives our customers the ability to scale up and down in a particular cloud depending upon the cost. If cloud provider one is cheaper, you move your workload to cloud provider one, you scale up in that cloud, scale down when the price starts to go up. So it gives you the flexibility. You can move around and make use of the car. If one is cheap, you can make use of that, and if it's no longer cheap, there's another one cheap, you can move to the other cloud. It gives you that flexibility. And the other one is basically reduced latency for end users. Right? With the help of content delivery networks, users can be redirected to the region that is closest to them. Right? Say, if there is a specific region, if a customer comes from that region, you may want to redirect that customer to your solution deployed in Cloud Provider 1. If any other customer, you want to redirect them to Cloud Provider 2. It gives you that option as well. Finally, it gives you access to more geographies. You want to expand your business, you want to go into a specific location, but you're running in Cloud Provider 1, and Cloud Provider 1 doesn't have service in that geography. What do? If you're running in multi-cloud, if your Cloud Provider number 2 is available in that geography, you can expand your business easily. So there are a number of advantages in moving to a multi-cloud. But the bottom line is that you should have a solution that supports your multi-cloud strategy. This is where we come in, Temenos and NuoDB. We have tested proven reference architectures available for multi-cloud as well as hybrid cloud solutions readily available. I'm more than happy to organize demos and presentations for those who are interested.
Nanda, thank you so much for taking us through multi-cloud and the term and making clear for all of us the benefits of multi-cloud. That was a terrific description. I think we're all now very clear on the benefits of multi-cloud. And yeah, thanks for mentioning the, it would certainly be, our pleasure to offer an in-depth demonstration of Temenos and NuoDB to any of our listeners and attendees today. So feel free to reach out and contact us. So with that, Nanda, I think we're about ready to wrap things up. And Josh, if you could check for us to see if we have any questions. We have a few moments left. Maybe we have some questions, and we can go ahead and take those.
Sure, Joe, and thank you guys. Thank you both. I found that to be very useful, very informative, and I appreciate the demo. It's always nice when you can see it as well as hear, what it is as you walk us through it. So thank you for that. We do have a couple of questions, few minutes here left. Nanda, if I can just come back to you briefly, there was a question. The demo was based in Google Cloud, but can we use the Temenos, the Transact NuoDB solution in private cloud too?
Yeah, sure, Josh. Yes, as you said, the demo was specifically in Google Cloud. I think I did touch upon it. Yes, the same solution can be run in AWS, Azure. Another question is specifically about private cloud. We have a specific software stack, stroke reference architecture available for those who want to make use of our cloud native, container native reference architectures meant for transaction NuoDB on-prem. Either they can use upstream open source Kubernetes, or they can run their solution in Red Hat OpenShift. We have published reference architectures and executable architectures readily available to make use of.
Okay, excellent. Thank you. Yes, indeed. Joe, if I can come to you now quickly, there was a question: how does it compare to traditional systems such as Oracle? Thoughts on that?
Sure. So, Josh, that is a very common question. I think whenever we have prospects evaluating NuoDB, it's they want to know just how does it compare to like an Oracle or a SQL Server or maybe another traditional database product that they're familiar with. And yeah, so what we can assure you is this is an area that NuoDB has focused on. Even long ago, prior to building out full distribution across clouds, NuoDB was first a relational SQL database product. And I touched upon it earlier, just a little bit about areas of anti-standard SQL, as well as supporting ACID transactions. I'll just add a little more there as well. So those who are familiar with relational database products and use things like, 4GL languages like, Oracle PL SQL or other database 4GLs that use stored procedures and triggers, NuoDB has all of it. It's a full mature SQL database product. So you can feel very comfortable when transitioning from an Oracle or a SQL Server to NuoDB, but at the same time get the distributed benefits of running in a cloud-native environment that we've described today.
Okay. All right. Thanks, Joe. So I think we get time for one more here, and I'll let you take this one. Are there particular types of financial services applications that NuoDB as a distributed SQL database is a good fit for?
Yeah, so as far as, the types of applications, for example, we would work with all of the Temenos-based SQL applications because our SQL is ANSI standard. As long as that financial application is using native SQL, then they're good to go. NuoDB is going to support that application extremely well. Again, as long as it's running the ANSI standard SQL, then NuoDB will be able to process those transactions.
Excellent, excellent. All right, well, to both of you, thank you from my perspective. I think there's one more slide here, Joe. If you want to wrap up on that slide, I'll let you do that. And for anybody who had questions that we didn't get to, we will follow back up and we will make sure that we get you answers to those questions following the webinar.
Great, thank you, Josh. Yeah, I'll just flip to the last slide. I just wanted to share one last slide with our viewers today, and that is next steps and how to get more information on Temenos and NuoDB. We have some links prepared, so you will get a copy of the presentation, and these links will take you off to areas where you can learn more about the product. Perhaps you may even want to demonstrate NuoDB or Temenos for yourself. We have some nice try it yourself, self-guided NuoDB Community Edition product that you can walk through. And then again, feel free to reach out to us if you're interested in a POC or running the product in more depth. I do want to take this opportunity to, Nanda, I'm very grateful for you joining today and sharing your perspective. It's been wonderful presenting with you today. Yeah, Nanda, would you like to also say a few words?
Sure, Joe. Joe, you are a great co-presenter. Thank you for your patience. And the listeners mainly, right? Thanks for tuning in today. And finally, Josh, thanks for facilitating. I really enjoyed. Thank you. Thank you, everyone.
Great. Thanks, everyone, for joining today.